Hello and welcome to helpyourmath.com. In this video, we are going to review how to calculate the slope of a line and the 4 different types of slopes that a line could have. How do we calculate the slope of a line when we're given 2 points? We will call the 2 points x sub 1 and y sub 1, and x sub 2 and y sub 2. The slope of the line we would calculate, we use the variable m for slope, and it's found by the change in y, so we say y2 minus y1, over the change in x. So it's the change in the y coordinates over the change in x coordinates. It tells us some information about the line without actually having to graph the line. And we usually leave the slope as a proper or improper fraction in simplified form or as an integer. Once we know the slope, what does it tell us about the line? If it's a positive slope, that means that the line goes up from left to right. So it looks something like this. Also, when we're calculating it, we might have a negative value over a negative value. This is a positive slope because negative divided by negative is positive. Or if we have positive over positive, so if A and B are both positive, that would also indicate a positive slope. So if both the numerator and denominator are negative, or if both the numerator and denominator are positive, that's a positive slope. That means that the line will be going up from left to right. A negative slope means that the line is going down from left to right. So there's our axes, and then maybe it's going down from left to right. And when we calculate it, that means we either have negative in the numerator or negative in the denominator, but not both, right? Both means we have a positive slope, in which case we might just put the negative out in front, indicating that negative slope. A zero slope means that the line goes straight across with no rise or no fall from left to right. In fact, it's a horizontal line. So just to change the color so it really stands out from my axes, it might look like that. And we would recognize that the slope is 0 if there's a 0 in the numerator. So if we end up with 0 over a, this indicates that we do have a horizontal line, and that is a slope of 0. Notice that 0 is a number. Very important to note there. And no slope means that the line only goes up and down, and it's a vertical line. So if we draw a picture of that, it might look something like this. Given that it's a vertical line, what that means for it to have no slope is that there's a 0 in the denominator, right? We can't divide anything by 0. That's mathematically impossible. So this, when there's a 0 in the denominator, indicates that we have no slope. Now let's look at some examples of calculating a slope and what kind of a slope it is. First, we're going to calculate the slope of the line that passes through these 2 points. If it helps, if you don't know the slope formula off the top of your head, I always suggest labeling, and writing down. The more you write down and label, the more you're going to remember it. So the slope is y2 minus y1 over x2 minus x1. And if either x1 or y1 are negative, you might want to put it in parentheses. Oftentimes we make the mistake of just saying, oh look, it's already a minus sign there, so I can just disregard the negative. No, we can't do that. Let's see if we come across that. So y2, we have negative 8, minus y1, there it is. So minus negative 3. Notice the minus is part of the formula, and then the negative 3 was the actual y coordinate that we're using there. x2 is negative 5, minus x1 is positive 7. So in the numerator, we have negative 8 minus negative. I might change this to plus positive. I get negative 5. In the denominator, I have negative 5 minus 7 over negative 12. A negative divided by a negative, remember what that means? That's positive 5/12. And then we can't simplify the fraction any further from there. So we end up with m equals, the slope of this line is 5/12. This is a positive slope, so that indicates that this line would be going up from left to right. In this example, we have negative 4, negative 1 is our first point, negative 4, 11 is our second point. So again, if you need to, label, x2 and y2, and the slope of the line, change in y over change in x. So we get 11 minus, I'm being really careful with those negatives, over negative 4, again being really careful with the negative. 11 minus negative, this is like the same thing as 11 plus 1 is 12 in the numerator. The denominator, I have negative 4 minus negative becomes plus positive. That makes a 0. I have a 0 in the denominator. This is undefined. So we can either say that the slope is undefined or we say no slope. And what else does this tell us about the line? This tells us that it's a vertical line. It's going to be a vertical line because vertical lines have no slope. In this example, again, I'm going to label, x2, y2, and the slope of the line, y2 minus y1 over x2 minus x1. Plugging in, we get 8 minus 8 in the numerator, negative 3 minus 6 in the denominator. In the numerator, we get 0. In the denominator, we get negative 9. So this ends up being a 0 slope, which is okay. That is an actual value, and that indicates that we do have a horizontal line. So having a slope that is equal to 0 is a horizontal line. And here's our last example. I'm going to go ahead and label these. As you get more practice with this, you won't need to label every time, but while you're getting used to it, the repetition really helps reinforce it in the brain. Skipping a step here, y2 minus y1 over x2 minus x1. We get negative 7 minus 5 in the numerator, 6 minus negative 9 in the denominator. Negative 7 minus 5 is negative 12. In the denominator, the minus negative, we could write that as plus positive. It's equivalent. 6 plus 9 is 15. So we have a negative over a positive. The slope is negative. And then 12 and 15 have a common factor. They're both divisible by 3. 3 goes into 12 4 times, and 3 goes into 15 5 times. So we end up with a slope. It's a negative slope. And what does that tell me about the line without actually drawing it? I know that as it goes from left to right, it's going down. These have been examples of the 4 different types of slopes that we might come across in mathematics. Slopes are something that tells us the rise to the run, the ratio of rise to run of any line. Thank you for stopping by.